All right, looks like we are live. Welcome to those of you who are here for our free lesson on Algebra 1. Today's topic is point slope form. In my opinion, the superior form for linear equations, all lines, anything like that. Welcome, welcome. I see F1 is here already. So early, bright and early. Welcome to the stream. If you can hear me, if you could put a plus in the chat, that would be great, just so I know that you can hear me. I'm not talking to myself. That would be quite awesome. But thank you for being here. Again, today's our free lesson on Algebra 1. We have point slope form. Excuse me. In order to chat today, you will have to subscribe to the channel in order to chat. If you're not about it, then you can always unsubscribe after. But in order to get the full experience with me today, I would like you to engage in the chat, participate, and that would be awesome. Another thing, you could access the workbook, which is in the description below, that very first link. That workbook has been professionally designed so that you do not have to write anything down and copy anything down from the screen. You can just focus on the learning. So just two little housekeeping things before we begin. For those of you that have never met me, I am Eddie. I'm the senior math teacher here at my EdSpace. I've been teaching for 9 years in high school classrooms and college lecture halls. I've private tutored every grade level from 6th grade math all the way to students in college preparing for graduate school. Excuse me. I have a bit of a lingering cough. I'll try to mute my mic whenever I have to cough. But back to what I was saying. Algebra 1 is super, super important for all students, especially because it is one of the foundational math classes that students take. And it's really make or break here on out, right? If I ever seen a student struggle in Algebra 1, they've continued to struggle later on as well if they didn't seek the proper support. But on the other side, if I saw students super confident and gain their confidence and build their confidence in Algebra 1, I've seen them just blossom and grow so much, taking AP Calculus in high school, getting that college credit before heading into college. Little things like that go a long way. I believe in 3 things during my lessons. I believe in having fun, because when we have fun, we tend to remember things better. Number 2, make mistakes. Don't be afraid to participate. Don't be afraid to speak honestly in the chat, because again, none of this is graded. Yeah, so you have nothing to lose, right? These are all opportunities. All my live lessons are opportunities for you to make mistakes, because when you make mistakes and you fix them, that's when true learning occurs, and that's when you retain that information 10 times as much. Hey Stone, welcome. And then third, ask specific clarifying questions. Not just I'm confused or I don't get it or can we do the whole problem again? Ask specific clarifying questions. Practicing that here with me will also help you when you go back into the classroom and you have a question during a lesson that the teacher is doing. It'll help you communicate what you don't know, and it'll help the teacher help you better as well. So those are the things that I would like you to focus on today as we begin. So let's get started. I love starting my lessons off with something called an APK, called Accessing Prior Knowledge. This is an entry point for all students to join on in. If they did not understand this or learn this in the past, then this is a good opportunity to get that first step in the door and get access to this lesson and furthermore. Throughout the lesson, you will notice, students, families, you'll notice that I start off really simple. I start off with really the building blocks to what we're about to challenge ourselves with today. And as we move on in the lesson, things will get more and more challenging as we build upon our solid foundation that we are trying to get right here. So let's get started. Here's our APK. Find the slope of the line segment, joining the following pair of points, and put your answer in the chat. So the slope of a line segment is also known as, you may have seen it as, rise over run. We saw this in pre-algebra. Rise over run is the change in y over the change in x. Now the change in y over the change in x, also known as delta y over delta x. Delta is a Greek symbol that stands for some change. Now, we've also seen this as y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. We call it y sub 2, right? Y sub 2, and sub stands for subscript. So that's why we say y sub 2 y minus y sub 1 all over x sub 2 minus x sub 1. I mentioned this because I actually really struggled with this when I was in high school, middle school and high school as well. When I first learned this, I was like, why don't we just call it y2 minus y1? I heard the teacher saying some other word in between the y and the 2. I never understood it until many, many years later. I was like, oh, they meant y sub 2, but I didn't understand that. English wasn't my first language, so I didn't understand it at first, but now that's why I mention it. Y sub 2 minus y sub 1, we call them subscripts because we write them a little under the line that we're writing in. So from here, we can notate, we can identify each of these points as their respective coordinates. X sub 1, comma y sub 1, and this one we can call x sub 2, comma y sub 2. So y sub 2 is 5, and if you know the slope already, let me know in the chat. 5 minus y sub 1 is 1, x sub 2 is 5, and x sub 1 is 3. And now we simplify. 5 minus 1 is 4, 5 minus 3 is 2. In the end, we have 2 as our final answer, and that's how we find slope. Give me a W in the chat if this made sense to you. Give me a plus if this is a little new to you, but you're confident you'll be getting it by the end of this lesson. So just a quick little temperature check as we move forward. W's and pluses. All right. Awesome. Let's keep it going. So here we're finding the slope between coordinates. Find the slope of the line segment joining each pair of points. So again, we're building off of what we did before. Before we've only worked with positive coordinates, but now we're facing some negative coordinates as well. We really have to be careful in distributing here. So letter A, we'll call this x sub 1, y sub 1, x sub 2, y sub 2. Now, some students may ask at this point, does it matter which one comes first? Like, can we put y sub 1 minus y sub 2? Absolutely. For slope, you can have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And you can also have y sub 1 minus y sub 2. You just have to make sure if you flip the numerator, you also flip the denominator as well, or switch them up. X sub 1 minus x sub 2. You cannot, however, do this and say x sub 2 minus x sub 1. You cannot do that because now they are not aligned. Notice how they are aligned for all of these on the left side. The one x'd out, they are not aligned. You cannot find the slope like that. It will not work. So let's find the slope for letter A. Y sub 2 is 8, y sub 1 is 2, x sub 2 is 2, x sub 1 is negative 2. So we have 6 over 2 minus a negative 2 is 2 plus 2, which is 4. And now we can simplify. We have 3 over 2. Let's check out letter B. Try it yourself. Let me know what you get in the chat if you're already confident in this. But for those of you that this may be new for, I'm going to go through it step by step one last time here. So we have the slope is equal to negative 7 minus a 5 all over negative 5 minus a negative 4. Now, putting these parentheses has become a habit for me. I think it's a really good habit. Why not use parentheses right when you can, when it's available for you? You'll never get things wrong by using too many parentheses, right? That's what I've noticed in the classroom. Students who use parentheses almost religiously never have made operational mistakes. So yeah, use them when you can. So negative 7 minus 5 is negative 12 all over negative 5 plus 4. That's negative 1. A negative divided by a negative is a positive, so we're left with just 12. Great. So now we're pretty confident in finding slopes between coordinates. Let's check out how we can use these. Oh, there's my dog. If you can hear him through the mic. Finding the slope between coordinates when we do not know one of those coordinates. For this example, k. We don't know what k is. But we do know that the slope is negative 6. So the slope is, again, the change in y over the change in x. So here we have x sub 1 and y sub 1 again, x sub 2, y sub 2, but this time we're also given the slope is negative 6. So all we're doing here is, for those of you that like substituting or plug and chug, that's exactly what we're doing here. M, the slope, is equal to negative 6. Y sub 2 is k, so we're just substituting in. Y sub 1 is negative 3. X sub 2 is negative 1. And x sub 1 is 5. And now we solve for k to the best of our ability. We have k minus a negative 3, that's plus 3. Negative 6 stays on the left side. Negative 1, and you subtract 5. You go 5 even lower. So now you have negative 6. In order to get rid of these denominators, in order to isolate k, the next step would be to get rid of the denominators. Multiply both sides by that negative 6. Negative 6 times negative 6 is 36. These cancel. Reminder that canceling means we are making something into a 1. Eliminating means we're making something into 0. So in this case, we are canceling, not eliminating. We have k plus 3, and now we will eliminate 3 from both sides. So k will equal 33, and that's it. So again, finding slope between coordinates, we're getting more and more challenging as we go here. Let me know in the chat if you ever have any questions throughout this. Give me some W's in the chat if you're understanding this. Pluses if you're feeling like this is still a little new and you're getting used to it, but it's not too bad. You can follow along with what I'm doing. And again, if you have any questions throughout, just ask. Happy to help. Okay, now let's enter equations of a straight line. Understanding our concept of slope is super, super important when trying to understand equations of lines. In this case, straight lines. We need to understand equations of straight lines before we can get into any curved functions as well. That's why we start with this. You have probably learned that the formula for a straight line is y equals mx plus b. We used to call this, if you know, let me know in the chat what we used to call y equals mx plus b. What form of a line is this called? We have a slope, and b is what we called our y-intercept. So we have slope, intercept form. This form of a line is great when we want to know what the slope and y-intercept are. Ooh, I should change that to r. But I will be showing you another way to find the equation of a line. Express this equation in the form, this right here. Now this, we may not be familiar with this form, but that's okay. A, B, C are all integers. Anyone can explain to me what an integer is in the chat? An integer, I've heard whole numbers, positive and negative. I've heard positive and negative whole numbers, right? So positive and negative whole numbers and 0. Do not forget 0. 0 is an integer. That's what makes the set of integers so special as well. So ax plus by plus c, a, b, c are all integers. They have to be whole numbers, cannot be fractions, cannot be decimals. That's the key here. This form is called standard form. Standard form. And whenever we have standard form, it's really easy to find either of the intercepts, x or y intercepts. So express y equals 2/5 x minus 3/5 in this standard form. Well, I need all of them to be integers. So the first thing I'm going to do is multiply both sides by the denominator, which is 5. The least common multiple of the denominators. Thankfully, both denominators are 5, so I can distribute this 5 to both. Now I have 5y is equal to 2x minus 3, and I can move everything to one side to make ax plus by plus c equal to 0. Typically what I do, you can do it either way, but typically what I like to stick with is keeping this a value positive, my coefficient of x positive. Currently, 2x is already positive, 2 is already positive, so I want to leave it there. I'm going to bring the 5y to the other side. That'll give me a negative 5y. Still got that negative 3. And now since there's nothing else on the other side of the equality, this is just equal to 0. And that's it. That's standard form, just like that. Now, determine the slope and y-intercept of this line. So now we're going backwards. We're going from standard form to slope-intercept form. in order to go from standard form to slope-intercept form, let me know in the chat, what is kind of the defining feature of this equation right here compared to standard form? And I'll give you a little hint. Standard form has all the variables on one side, whereas slope-intercept form has just a y variable isolated. So y variable isolated by itself, just like this, I want it by itself. So in order to do that, I'm going to move everything else to the other side. 2y will equal negative 3x plus 7. And I'm going to divide everything by 2 to get negative 3 halves x plus 7 over 2. And that is how I found my slope and y-intercept. Another common misconception that may occur here is that some students might say the slope is negative 3 halves x. This would be incorrect. X is a variable. The slope is the coefficient of that x variable. The slope is just negative 3 halves. The x is simply a variable. 7 halves is our y-intercept. But if we want to be a little more clear about what a y-intercept is, a y-intercept occurs whenever our x value is 0. So the y-intercept is also known as a point, 0, 7 over 2. Okay, now, instead of using slope-intercept form like we just did, let's explore a better way of representing lines. Given a point, x sub 1, comma y sub 1, find the general equation of a straight line. So notice how this says x comma y here. It can be any point on the line. We're not calling it x sub 2 comma y sub 2. Let's find the slope of this line. So the slope of this line would be y minus y sub 1 all over x minus x sub 1. And that's equal to my slope of m. Now, let's try to isolate all the y's. So I multiply both sides by x minus x sub 1. X minus x sub 1. So these cancel. And all we're left with is y minus y sub 1 is equal to m times x minus x sub 1. And then, students, this is what we call point-slope form. It is directly derived meaning coming from the slope formula. The slope formula was y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Slope-intercept form, boom, love this one. Y minus y sub 1 is equal to m times x minus x sub 1. M is our slope. Let me label these. M is our slope. And then, let me use purple. Y sub 1, x sub 1 is our point. Our one point that we know from the equation will be x sub 1, comma, y sub 1. And that's why we call it point slope. We only now need one point and one slope to find the equation of a line. And I will tell you right now, for those of you that are in Algebra 1, you are going to see this again in geometry, in Algebra 2, in AP Calculus AB, in AP Calculus BC, in statistics, and any STEM course you take that involves any type of straight lines, even in micro and macroeconomics, when you're talking about supply and demand, things like this. You will always be using lines, and I will tell you, I guarantee you, point slope form will be the most useful form of a line that you will be using, and that's why I decided to make today's free lesson about point slope form. You will need this for every single class here on out. If you are confident and master this, you'll be so confident in anything that has to do with lines or slopes, as a matter of fact, in future courses. So let's take a look at a couple problems. Find the equation of a line that goes through negative 2, 7 and has a slope of 3. So we are told that our point is negative 2, 7, and our slope is 3. Now, if we wanted to use slope-intercept form, I have my slope, but I don't know what my intercept is, right? I don't know what my y-intercept is. In order to find the y-intercept, I'll have to create a quick little visual, a quick little graph and go up 3 over 1, up 3 over 1 to get to my y-intercept, where the x value is 0. However, now that we know point slope form, all we need to do is plug in these values. We have y minus 7. 7 is my y sub 1, equal to slope, which is 3, x minus x sub 1. X sub 1 is negative 2. And now we solve for y. We have 3x plus 6. Where did the 6 come from? Negative times a negative is positive 2, times the 3 is positive 6. 2 times 3 is 6. And now we add 7 to both sides. We get 3x plus 13. And that's it. Isn't that crazy? So this is letter B. Now let's try it with letter A, see what happens. So we know y is equal to 3x plus b. We know x comma y is negative 2 comma 7. So when we plug these in, we get 7 is equal to 3 times negative 2 plus b. So 7 is equal to negative 6 plus b. B will equal, add the 6 to both sides, 13. And now we plug in this back into this b. So we get y is equal to 3x plus 13. So which one would you rather use? I'll leave that up to you. For me, I think that point slope form is the superior linear equation form. It's the most useful one out of all of them. Standard form, slope intercept form, point slope form. Point slope form is the best one. However, we do need to know how to use all of them and what each of them are called. All right, let's try this one. Find, in each case, the equation of the straight line with the following conditions using our point slope form. So for letter A, we're given the slope and we're given a point. We're given a slope equal to 2/5 passes through the point negative 3 comma 5. Now from here, what you may notice is that we can simply just plug in. Right? We can simply plug in. We have an x sub 1 here and a y sub 1 here, and we have our slope. If you have an answer to this already, or maybe even that first step, let me know what you think it is in the chat. Let me see if any of you are getting this. Reminder that if you want to chat, you do have to subscribe to the channel in order to chat for today. Let me know what you got. You have the slope is equal to m equals 2/5, and the point is negative 3 comma 5. Let me know what you get in the chat. I'll start it off for us. I'll color code to start it off for us. Y sub 1 is 5, so that's what's going to go in for this y sub 1. Then we have x sub 1 is negative 3. That's what's going to go right here, negative 3. And last but not least, our slope is 2/5. That's what's going to go right here. And I'm just going to substitute here. That's all I'm going to do. Just substitute, plug and chug. Y minus 5 in green is equal to 2/5 times x minus x sub 1, which is negative 3. Negative 3. And boom. All we need to do from here is use our knowledge of just like number operations to isolate the y. And we've got our equation of a line. So we have y minus 5 is equal to 2/5 x. Now this is a plus 3. Negative times a negative is a positive. Positive 3 times 2/5 is 6/5. Now we're going to add 5 to both sides. We get y is equal to 2/5 x plus 6/5 plus 5. But in order to add these two numbers, I'm going to do it on the side here. We'll need 6/5 plus 25 over 5. A common denominator where I multiplied 5 by 5 over 5 so that our denominators are the same. Once we add these up, we get y is equal to 2/5 x plus 31 over 5. Okay, let me know in the chat, W's, if you're fully clear on this. And if not, put a plus in the chat and ask those questions. Ask those questions. I'm looking at the chat I look at the chat every 5 to 10 seconds, even in our course that's already running throughout this year. Yeah, the chat is always going crazy. super engaged students. They're constantly chatting. I think there was some stat. It was like there was one stream where students sent an average of like 40 to 50 messages within that 55-minute lesson. Yeah, so students are really engaged throughout every single lesson. I'm constantly asking questions where they can stay engaged as well. Let's check out letter B. So letter B, we have 2 points this time. We're not given the slope, but thank goodness we talked about finding slopes earlier in our APK, our access to prior knowledge, and we had some problems that we solved as well earlier. So let's find the slope first. And for now, let's identify each of these as x sub 1, y sub 1, x sub 2, y sub 2, and plug in. 0 minus a negative 1.5 all over 7 minus 2. That gives me 1.5 over 5, and I know that will be 0.3. 1.5 divided by 5, well, 15 divided by 5 is 3, but since this is not 15, it's just 1.5, we got that 0.3. Now, in the chat, let me know which point would you rather use? 0.1 or 0.2? Which point would you rather use to find the equation of this line that passes through these 2 points? 0.1 or 0.2? Yeah, most students would say 0.2 because number one, we don't want to work with any negative numbers. And number two, whenever we have a 0, work with the 0, right? The 0 solves so many problems. It helps us speed up the process every single time. So we're going to use 7, 0 and plug it into point slope form. So if y minus 0 is equal to our slope of 0.3 times x minus 7, and now we distribute the 0.3 to the x and the negative 7, and voila, there is our final equation of a line that passes through the points 2, negative 1.5 and 7, 0. Alrighty, we are nearing the end of our free lesson here. This is our final big problem. This is going to be a challenge, somewhat of a challenge problem here. So if you understood everything till now, give me a W in the chat. But if you feel like you're not quite there yet, give me a plus. And hopefully by the end of this following slide, you're back at that W. All right, let's take a look. We have a straight line. L sub 1 has slope negative 2 and passes through the point 2, negative 3. Boom, there's our slope, there's our point. What can we use? Point slope form. So letter A, we can say y minus y sub 1 is equal to m times x minus x sub 1. And now we solve for the equation of the line L sub 1. We have y plus 3 is equal to negative 2x plus 4. Now I subtract 3 on both sides. I'm left with 4 minus 3, which is a positive 1. Let's do the same with letter B. Letter B says passes through these 2 points, negative 4, negative 1, and 3, 1. So very similar to the previous slide, letter B, where we had to find our slope first. And that's what we'll do. We'll find their slope first. We'll label these as x sub 1, y sub 1, x sub 2, y sub 2, and just plug and chug. Again, the slope formula is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So we have 1 minus a negative 1 all over 3 minus a negative 4, and we get 2 over 7. Okay, there's our slope. Which point do we want to use? This is a general rule of thumb. This is a good habit to practice as well for all of you here. Always work with the positive numbers when you can. There are 3 types of numbers that I try to not necessarily avoid, but if I can actually, avoid, because they lead to a higher probability of making careless errors, especially on exams when you have a lot of questions that you have to go through. Those three types of numbers are first, negative numbers. It's really easy to miss out a negative. It's really easy to forget to distribute a negative. Number two, fractions and decimals. Always try to simplify fractions when you can. And number three, be really, really big numbers. Especially when we have fractions and things like this with really, really big numbers, before operating with them, try to simplify as much as possible, because when we work with bigger numbers, there's a higher chance we make mistakes than when we work with smaller numbers. So little things here and there that I try to preach every time things like this come up. So in this case, we are going to use the point 3, 1. But you could use either one, you'll get the same exact answer. So point 3, 1. Let's plug it into point slope form. Y minus 1 will equal 2/7 times x minus 3. Again, point slope form was y minus y sub 1 equal to m times x minus x sub 1. Some of you may be wondering at this point of the lesson, well, why can't we use the other point? Well, let's take a look and use that other point as well. If we use the point -4, -1, then here's what would have happened. We have y minus a -1 is equal to 2/7 times x minus a -4. Once we have this, I'm going to distribute. I'm going to distribute properly, and I get y minus a -1, that's y plus 1, equal to 2/7, that's still our slope, times x plus 4. So now I have y plus 1 equal to 2/7 x plus 8/7. Now I'm going to subtract 1 from both sides. But 1, like I did here, is the same as 7/7. 1 is the same as 7/7. For those of you that may not understand why we have this 7/7, it's so that we have common denominators, so that we can operate with the other fractions over 7 on the other side of the equality. So when we subtract 7/7 from both sides, we get y equals 2/7 x plus 1/7. And guess what? These are exactly the same thing. And this works because, reminder, we were given these 2 points and we found the slope using these 2 points. So the line, whatever the slope that we found was, should still go through both of these 2 points. So regardless of whether or not we use one point or the other, we should get to that same exact answer every single time. Okay. Put a W in the chat if today's class helped, if you learned even one new thing, or if you just enjoyed being here in general. Put a W in the chat, because we have a lot more to come here. Today was just one piece of Algebra 1. I have an entire curriculum running through the month of May, beginning of June, and we have a lot to cover. So today was just one piece, just point slope form, but we have so much more to learn. And that's why we have this special deal going on today. Try My Headspace for 7 days, just $7. You get full access. You can cancel anytime. And this is what you get. Just like today, you get a lesson like today twice per week, live, interactive, engaged with the chat, and all these lessons are recorded. Even today's is recorded so that you can revisit at any time. Let's say you're not covering this in school right now. That's okay, because when you do end up covering it in school, you can come back to this, review it, see how I taught it, and get that extra boost, right? Let's say you have a syllabus for your class already, so you know exactly what's coming up. Let's say you see it coming up next week, but we learned this way back in November. Then you'll be like, oh, let's go back to our November module, click on point slope form, review that, or do the practice problems again, check out those video solutions. And this is what I'm talking about. Here are the workbooks that you were able to access today in the description link. And you get practice problems after every lesson, a unique set of practice problems so that you can prove to yourself that you've mastered this material. But fear not. If you did not feel like you've mastered it and you didn't do well on those practice problems, I have another video going through every single practice problem step by step, where it's basically another shorter lesson that you have access to once you complete those practice problems to make sure that you understand it once more. So it gives you that extra practice as well. Not only are you practicing with me during my live lessons or while viewing the recordings of the lesson, but you also get these practice problems that you can review with me through these video solutions that you can go to any one of the questions. You don't have to watch the entire thing. You can just go to the question that you need help with. And don't just hear from me. Over 17,000 students have succeeded using my EddSpace. Hundreds of 5-star reviews. And yeah, I mean, it speaks for itself. And so if you're interested, grab your parents for 60 seconds. This is not a sales pitch. I'm a teacher. This is more of to get, you signed off and get access to my course. And you probably can't do that yourself. If you can, that's awesome. But we would need your parent here just for 1 minute. Here we go. Hey parents, your child just finished a free algebra lesson and wants to try it out for 7 days. $7 for 7 days starting Monday. Or for Algebra 1, it'll be Tuesday. And I'll get into that schedule in a little bit. It's a complete money-back guarantee. You can cancel with one click. And after that, if you'd like to continue with me, continue learning with me at my EddSpace, it'll be just $149 a month for 7 to 8 lessons per month, including those practice problems, including those video solutions, including the live lessons, all recorded that you can access anywhere and everywhere after that lesson has been completed. For $7, again, you get all of this: the workbooks, step-by-step video solutions, practice problems, live lessons twice a week, all of them recorded for unlimited amount of replays. Here's the lesson schedule. Algebra 1 meets on Tuesdays and Thursdays, 5 p.m. Pacific time, 7 p.m. Central time, 8 p.m. Eastern time. Each lesson is 55 minutes. And we meet every week other than holiday weeks like Christmas, New Year's, Thanksgiving, spring break, things like this. But other than that, every single Tuesday and Thursday, 5 p.m. Pacific time. I'm based in Los Angeles, so that's what I go by. 55 minutes for twice a week. And to protect you from any risk, as I mentioned before, we provide a full refund guarantee. It's absolutely no risk for you. So if you're interested, scan this QR code to start. If the QR code is not working, myedspace.com/7 is another place that you can go as well. It's a 7-day math pass. Again, just $7 to try it out. On our platform, not on YouTube. We have our very own platform that's, obviously beautiful. It's amazing, where you can access everything: the lessons, the chat, the practice problems, the workbooks, the video solutions, every single one of the past lessons as well. So check us out, myedspace.com/7, or if you have your phone out right now, scan that QR code. If you have any questions, I'll be taking some questions here as well. So make sure, if you want to ask those questions and chat, you need to be subscribed to my channel. That's just one of the required things on YouTube that I cannot control. So if you have any questions, I'll be here for a minute or so. But otherwise, thank you for checking us out. I hope to see you soon, and I'm excited to have you join and begin your journey with me at my EddSpace. So early, right? Algebra 1. So early. Y'all are already here, right? Algebra 1 is the beginning of all the math courses that you'll be taking in the future. You need that solid foundation. So I'll be seeing you soon. Thank you, everybody, and see you next week. Bye-bye.